Welcome students. In this lecture we will learn integration of irrational functions. Now for this we need three important formulas that are very important and are applied in solving integrations of this type. So what I will do is I will go on to write those integral formulae for your attention. So the first one is integral of square root of x squared negative a squared times dx. Now this is equal to x over 2 root of x squared negative a squared negative a squared over 2 times log of x positive root of x squared negative a squared followed by arbitrary constant c. Now the next integral is integral of root of x squared positive a squared times dx. This is equal to x over 2 root of x squared positive a squared over 2 ln of x positive root of x squared positive a squared positive arbitrary constant c. The next one is root of a squared negative x squared times dx. This is equal to x over 2 root of a squared negative x squared positive a over 2, and in this case it is sine inverse of x over a positive arbitrary constant c. Now I can understand that all of these things, they look a little bit complicated, but with some practice you will be able to achieve these formulae. Now you can clearly see the similarities in these formulae. Now for example, integral root of x squared negative a squared times dx, integral root of x squared positive a squared times dx, integral root of a squared negative x squared times dx. In all of these cases you can see that x over 2 x over 2 x over 2 is appearing, followed by the integrand which is present there. Now if a squared is negative, then we start with a negative sign. If a squared is positive, we start with the positive sign. And since we got a squared everywhere, we got a squared over 2, a squared over 2, a squared over 2. Now for the first quantity, it's going to be ln of x positive the integrand. Second quantity is going to be ln of x positive the integrand. Now for the final one, we have already studied about the integral root, or I should say integral dx over root of 1 negative x squared, right? So this is a popular integral. Now this will lead us to sine inverse. So since we got a term like this, a squared negative x squared, we are getting sine inverse of x over a. So that is one of the ways in which we can remember these integral formulae. Now what I will do is I will start off in proving the first formula, and you will be in a position to give the proof for the other things. So foremost what I will do is I will start off with proving this. So we expected to obtain the integral and show that this is equal to the right hand side. So let us just write the given quantity, which is integral root of x squared negative a squared times dx. Now I wish to apply integration by parts. Now we know the formula integral u dv is equal to uv minus integral v du. So in this case what I wish to do is I will take my u to be equal to root of x squared negative a squared and my dv to be equal to 1 times dx, so it's going to be just dx. Now I will have to differentiate this, so I'm going to rewrite this as x squared negative a squared raised to the power of 1 over 2. Now differentiating both sides, we get, so this is going to be du is equal to 1 over 2 times x squared negative a squared raised to the power of 1 over 2 negative 1 times differentiation of x squared, which is going to be 2x. So if I were to rewrite this, my 2 that I see here would be cancelled with the 1 which I see in the denominator, thereby giving me x times of x squared negative a squared raised to the power of half negative 1 over 2 will give me negative half, which is nothing but x over, I can push it to the denominator, thereby giving me x squared negative a squared. So this is my du. right? Now let us use this formula and write the question. So if I were to take this as 1, now using 1, we now have, so integral u is root of x squared negative a squared, my dv is dx, this is equal to u times v, my u is, I'm going to write it as root of x squared negative a squared, and my v, okay, let's go and obtain our v. Now integrating, we would get v is equal to x. So this is going to be x, I'm going to place x here, followed by a negative sign, negative integral, my v is x, my du, so I need to actually place a dx here, so there is a dx here, so this is going to be x times dx over root of x squared negative a squared. So this can be rewritten as x times root of x squared negative a squared negative integral x squared times dx over square root of x squared negative a squared. Okay, so now what I wish to do is, we have this integral sign, right? So what I will do is, I will start off with this particular line, let I be equal to this, let I be equal to this quantity, right? This entire quantity is equal to I. So if I were to take that as I, on the left hand side I will have I is equal to x times root of x squared negative a squared negative. Now what I wish to do is, I would like to add a squared and remove a squared. So that's going to be x squared negative a squared positive a squared times dx over square root of x squared negative a squared. Now this can be further rewritten as x times root of x squared negative a squared negative integral. I can split this quantity as x squared negative a squared times dx divided by square root of x squared negative a squared. Then I got a negative sign, so it's going to be negative of integral a squared times dx over root of x squared negative a squared. Now we know that if I have a quantity like this, say 2 divided by root 2, I can rewrite this as root 2 times root 2 over root 2, and root 2 can be cancelled, giving me root 2, right? That's exactly what I'm going to do. So this is equal to x times root of x squared negative a squared negative integral. If I were to write this as root of x squared negative a squared times root of x squared negative a squared times dx divided by root of x squared negative a squared negative integral a squared times dx over root of x squared negative a squared. So clearly root of x squared negative a squared, x squared negative a squared can be cancelled, giving us x times root of x squared negative a squared negative integral root of x squared negative a squared times dx negative integral a squared times dx over root of x squared negative a squared. Now this is I, right? Because we have taken this to be as i's, and on the left hand side I also have a I, so this is going to be negative I, so I push it to the left hand side, so it's going to be I added with I is equal to x times root of x squared negative a squared negative a squared times integral dx over root of x squared negative a squared. So this is going to be 2 times I is equal to x times root of x squared negative a squared negative a squared. Now this is a famous formula which we already know. So this is nothing but ln of modulus of x positive root of x squared negative a squared, right? Now we need only I, okay? So if I were to push this on the right hand side, of course we have to place the arbitrary constant. This is going to be I is equal to x over 2 times root of x squared negative a squared over 2 ln of x positive root of x squared negative a squared positive, because 2 is coming here, so it's going to be c over 2. Now I can rewrite this as I is equal to x over 2 times root of x squared negative a squared over 2 ln of x positive root of x squared negative a squared positive capital C, arbitrary constant C. So this is a good place for us to draw the red line. Now if you were to take this and compare it with the formula, this is the first one, x over 2 root of x squared negative a squared over 2 times ln of x positive root of x squared negative a squared positive arbitrary constant. See, that is exactly what you got. X over 2 root of x squared negative a squared over 2 times ln of x positive root of x squared negative a squared positive arbitrary constant C. So that is how we prove it, students. We can move to the next question. Students, we are expected to integrate integral square root of x squared negative 8x positive 7 times dx. Now what I wish to do is I would like to rewrite the quantity inside the square root as a perfect square. Now clearly you can see that what you need to do first is take the coefficient of x, which is 8, you divide by 2, you get 4. So all you need to do is just simply place that 4 with the sign. So it's going to be x negative 4 and raise it to the power of 2. So if you were to expand this is going to give you x squared negative 8x positive 16. Now you got x squared here, negative 8x here, right? But you need to have a 16. So what I will do, I will just rewrite this as root of x squared negative 8x positive 16. Okay, so now I can clearly represent this thing with this perfect square. But 16 is added, so you have to remove the 16. So that's exactly what I'm doing. But there is also a positive 7. So place that positive 7 along with the differential operator dx. So these can be clubbed together. So I can rewrite this as integral root of x negative 4 raised to the power of 2. Negative 16 added with positive 7 would give us negative 9 with the differential operator dx. Now this can be rewritten as root of x negative 4 raised to the power of 2 negative 3 squared times dx. Now this is very similar to the popular formula which we just saw a minute ago, which is integral root of x squared negative a squared times dx is equal to x over 2 times root of x squared negative a squared over 2 times ln of modulus of x positive root of x squared negative a squared plus arbitrary constant C. So using this we get using this in 2. So I will write it as 2. So this is going to be equal to, so 2 will be rewritten as, in place of x I've got x negative 4 divided by 2 times the root of the quantity there, x negative 4 raised to the power of 2 negative 3 squared, negative, in place of a I've got 3, so that's going to be a squared, it's going to be 9 over 2 times the ln of x is going to be x negative 4 positive root of this quantity x negative 4 raised to the power of 2 negative 3 squared with the modulus sign, positive arbitrary constant C. So this is the final solution. We were able to achieve the solution because of the formula which we had obtained, and this is a good place for us to draw the red line. Of course you can perform some simplification if it is required. If not, that is a good place for us to stop and proceed to the next question. Students, let's do this question. We are expected to integrate integral root of 1 positive x squared times dx. Now what I wish to do is I would like to rewrite the given question as integral root of x squared positive 1 squared times dx. right? Now this is similar to, we know that integral root of x squared positive a squared times dx is equal to x over 2 times root of x squared positive a squared positive a squared over 2 times ln of modulus of x positive root of x squared positive a squared positive c. So this is the formula. Now if I were to take this as 2, using this into 2 can be rewritten as integral root of x squared positive 1 squared times dx is equal to x over 2 times root of x squared positive 1 squared, positive a is 1 squared over 2 times ln of x positive root of x squared positive 1 squared modulus sign and then positive arbitrary constant c, and this is the solution for this question. So because we know this formula, the solution is easily obtained. Now one word of caution when you are dealing with questions of this nature. Now do not think integral root of 1 positive x squared times dx is equal to 1 positive x squared raised to the power of, this is 1 over 2, so it's going to be 1 over 2 positive 1 divided by 1 over 2 positive 1 positive c. Do not do that. This is not equal, right? So if you were to do this, you would land up with a negative score, or it would be simply marked as 0. So at this point, you cannot integrate this particular quantity in this fashion. So this is a caution which you will have to take into account or take notice of. So having mentioned this, we will move on to the next topic. So the topic that we would do now is integrating irrational algebraic functions. Now there are 4 types in this, so this is type 1. In type 1, the form is 1 over linear function times the root of a linear function. This is type 1. In type 2, we got 1 over a quadratic function with a root of a linear function. This is type 2. Now in type 3, you have a linear function with a root of a quadratic function. So this is a quadratic with a root of a linear function. This is linear with a root of a quadratic function. So type 2 and type 3 are repetitive with a twist. Now finally you have type 4. In type 4, the form is, in this case it's 1 over linear times root of a linear quantity, right? So this would be 1 over q times root of a quadratic function. So these are the 4 types that we would be learning to solve in this lecture. So we are going to see, or I should say look into type 1, and the illustration would be of the form integral 1 over ax positive b times the root of p times x positive q. Of course there is a differential operator there. Now whenever you are given this form, you have to take px positive q to be equal to t squared. So this is a substitution, because the type here is 1 over linear times root of linear. So remember this substitution. This is the substitution that you will have to use. So let us see an example to understand this type better. So we are asked to integrate integral dx over x positive 2 times root of x positive 1. So as I mentioned to you, the quantity inside the square root we need to make the substitution for, and that would be let x positive 1 be equal to t squared I differentiate both sides, I would get dx is equal to 2 times t times dt. And from here I can also write x to be equal to t squared negative 1. So therefore this original integral is rewritten as integral. In place of dx I'm going to substitute 2 times t times dt over, in place of x I'm going to substitute t squared negative 1 positive 2 times root of, in place of x positive 1 I'm going to substitute t squared. This is rewritten taking 2 out. I have a t and a dt divided by negative 1 added with 2 would give me positive 1, so that's going to be t squared positive 1 times root of t squared will give me t. Now clearly I can cancel the t's here, and that would give me 2 times integral dt over, I can rewrite this as 1 positive t squared. But what is this? This is actually a formula that we know. We know that integral dx over 1 positive x squared is nothing but tan inverse of x positive c. Right? We know this formula. So by this formula, this is going to be equal to 2 times tan inverse of t, which is nothing but 2 times tan inverse of, what is my t? My t squared is x positive 1, so my t is going to be root of x positive 1. Of course we have to place the arbitrary constant c, and this is a good place for us to draw the red line. So this is the solution for this question. Let us do one more question. This is going to be the next example. So we are expected to integrate integral dx over root of 2x positive 1 times root of 4x positive 3. Now clearly this is of the form type 1, which is nothing but 1 over linear times root of linear. If that be the situation, we will take the quantity inside the square root to be as t squared. So let 4x positive 3 be equal to t squared. So from here, this would mean that 4 times x is equal to t squared negative 3, and clearly x is equal to t squared negative 3 divided by 4. So this is just to extract x. Now if I were to differentiate both sides, differentiating both sides, this would give me 4 times dx is equal to 2 times t times dt, which means dx is equal to, I can push the 4 down, so it's going to be 2 times t dt divided by 4, which is equal to t over 2 times dt. So this is my dx. So the original question can be rewritten as, in place of dx, it's going to be t dt. Of course there is a 2 there, I'm going to place the 2 here, over 2 times x. My x is t squared negative 3, so it's going to be 2 times of t squared negative 3 divided by 4. I have a positive 1 times square root of 4x positive 3, which is t squared. Now I can rewrite this as, now 2 divides here 2 times, this is t squared negative 3 divided by 2 positive 1 times root of t squared, that's going to be t. So clearly what we have here is the t that we see here can be cancelled. So I'm going to rewrite this as, this is equal to integral 1 over 2 is here, dt is here, divided by, I take 2 as the LCM. So that would give me t squared negative 3 positive 2 divided by 2. Right? And if I were to flip this, now the flipping is possible. So it's going to be 1 over 2 times 2 times dt over t squared negative 3 positive 2. That's going to be t squared negative 1. So clearly the 2 that we see here can be cancelled. So now this is actually a popular formula. So let me just show you the formula over here. Now we know that integral dx over x squared negative a squared is equal to 1 over 2a times ln of x negative a over x positive a, positive arbitrary constant c. This is actually a popular formula which we have already studied and applied in many cases. So using that, this is actually 1 squared, right? So it's going to be 1 over 2a, a is 1 times ln of x is t negative 1 over t positive 1. I'm not going to place the arbitrary constant as yet. So this is equal to 1 over 2 times ln of t. What is my t? My t squared is 4x positive 3. So my t is going to be root of 4x positive 3 negative 1 divided by root of 4x positive 3 positive 1 positive arbitrary constant c, which is a good place for us to draw the red line. So this is a beautiful question, and we have managed to squeeze this question in this space that we have. So we will move on to the next question, students. Students, we are expected to solve this question. Now this is of the form 1 over q times root of L. So this is the next type. So the question is integral dx over x squared positive 5x positive 6 times root of x positive 1. Now what we will do is we will take x positive 1 to be equal to t squared. Now from here x is equal to t squared minus 1. So we are just extracting x from here. Now from this particular equation we will differentiate both sides. Differentiating both sides we get, so what happens here, this is dx, this is equal to 2 times t times dt. So if I were to substitute this in the original integral, this is going to be equal to, in place of dx it's going to be 2 times t times dt divided by, in place of x I'm going to substitute t squared negative 1. So this is going to become t squared negative 1 raised to the power of 2 positive 5 times t squared negative 1 positive 6 times root of x positive 1, which is t squared. So this is what we have got. So I can rewrite this to be as equal to 2 times integral, so t times dt divided by, now let me expand this t squared negative 1. So that's going to be t raised to the power of 4 negative 2 times t squared positive 1 positive 5 times t squared negative 5 positive 6 times root of t squared will give me t. So we can cancel this t and add negative 2t squared with 3t squared and add 1 to 6, that's 7, and from 7 you can take away negative 5. So that is going to be equal to 2 times integral dt divided by t raised to the power of 4 positive 3 times t squared, and this is going to be positive 2. So this is a quadratic equation in disguise. So suppose you were to take t squared is equal to say some p, this is rewritten as p squared positive 3 times p positive 2. If you can rewrite this in factored form as p positive 2 times p positive 1, this will give you back this expression. So p into p is p squared 2p and a p that will give you 3p, 2 times 1 will give you 2. Now you can revert p to t squared, so that's going to be t squared positive 2 times t squared positive 1. Right, this is done just for understanding. You don't have to show this there. So just to gain an understanding, I've just placed this there. So this is equal to 2 times integral dt over t squared positive 2 times t squared positive 1. Now actually I can rewrite 1 using this. So this is equal to 2 times integral, 1 is rewritten as t squared positive 2 followed by a negative sign t squared positive 1 times dt, okay, divided by t squared positive 2 times t squared positive 1. So clearly if you distribute the negative sign you get negative t squared, positive t squared, negative t squared will get cancelled. You have a negative 1. 2 added with negative 1 will give you back the 1 that you have here, right? So what I'm going to do is I'm going to use the algebraic property. What is that? If you have something like this, a positive b over c, you can distribute it, or you can rewrite it as a over c, positive b over c. You can always do it like this. So that's exactly what I'm going to do. So this is equal to 2 of integral times dt divided by t squared positive 2 times t squared positive 1 negative integral t squared positive 1 times dt t squared positive 2. So t squared positive 2, t squared positive 2 can be cancelled. T squared positive 1, t squared positive 1 can be cancelled. And you can rewrite this as 2 times integral dt over t squared positive 1 negative integral dt over t squared positive 2. Now what is this? Now we know that integral dx over 1 positive x squared is tan inverse of x positive arbitrary constant c. We know this formula, right? So I'm going to apply this formula. So how I'm going to apply this formula? I'm going to rewrite this as 2 times integral dt over 1 positive t squared negative integral dt over root of 2 raised to the power of 2 positive t squared. So this is going to be equal to 2 times integral of this is going to be tan inverse of t negative 1 over a, that's 1 over root 2, tan inverse of t over root of 2. I'm not placing the arbitrary constant as yet. I want to revert t to x squared or to the x variable. So t squared is this. So my t would be, so from here t would be root of x positive 1, right? So that's exactly what we need to do. So this is going to be 2 times integral tan inverse of root of x positive 1 negative 1 over root 2 tan inverse of root of x positive 1 divided by root 2 positive arbitrary constant c, and this is a good place for us to draw the red line. So this is a beautiful question, and please practice this. Students, it's time to write the note. If you are given a type of this fashion, 1 over linear times root of a linear quantity, or 1 over q times root of a linear quantity, if one of these are given, then you will have to take or make this quantity which you see here to be as, say for example, let me write it as L prime and L prime. The substitution that you will have to do is let L prime be equal to t squared. So this is just done so that there is some identification, because you have L being featured here. So that's why I've just taken L prime. So I hope this illustration which I have done, the previous illustration which I have done, emphasizes the substitution technique and the solution that we have obtained. So now it's time to move on to the next types. Students, in this type we would be given integrals of this fashion: 1 over a linear times root of a quadratic function or a system of this fashion. Now you will have to make a substitution. So let us for example take this question. If you are given an integral of this fashion, integral dx over ax positive b times the root of, say, px squared positive qx positive some r, something of this fashion. Now this is a quadratic, this is a linear. Now if you have a system of this fashion, you can, or you need to make the following substitution. Take ax positive b to be equal to 1 over t. So this should be the standard substitution that you will have to use. Okay. Now, just for the sake of being consistent, I'm taking it as lowercase r. Okay. So with this in mind, let us solve this question. So solve integral dx over x positive 1 root of 1 positive x negative x squared. So clearly this is a quadratic quantity, quadratic function, and you got a linear function. So you have a linear and a quadratic being placed within the square root. So what we are going to do is we are going to make the following substitution. We are going to state that let x positive 1 be equal to 1 over t. So if x positive 1 is equal to 1 over t, clearly x is equal to 1 over t negative 1. And differentiating both sides, this is going to give me dx is equal to negative 1 over t squared times dt. So let me just box these quantities. So what happens to the original integral? This is equal to, in place of dx is going to be negative 1 over t squared times dt divided by, in place of x positive 1. So this is how the quantity is given, x positive 1 times root of 1 positive x negative x squared. In place of x positive 1, we are going to have 1 over t root of 1 positive, in place of x we are going to have 1 over t negative 1 followed by a negative sign. In place of x is going to be 1 over t negative 1 raised to the power of 2. Now clearly the positive 1 negative 1 can be cancelled. I can flip this t to the numerator. So it's going to be t over t squared with a negative sign integral dt divided by root of, now you got 1 over t negative, I expand this, you get 1 over t squared, probably I'll place them in the parenthesis first, negative 2 times, so it's going to be 2 over t positive 1. Now this is equal to, now clearly I can cancel a t here, so that's going to be negative integral dt over t divided by root of, now I have a 1 over t, negative 1 over t squared, positive 2 over t, and a negative 1. Now I can add 1 over t and 2 over t, so that would give me 3 over t, right? So this is equal to negative integral dt over t root of, that's divided by root of 3 over t negative 1 over t squared negative 1. Now let me take the LCM, integral dt over t divided by root of, I'm taking the LCM as t squared, so if I were to take t squared as the LCM, this is going to be 3t negative 1 and negative t squared. So if I bring the t squared out, it's going to be 1 over t, so I can flip the 1 over t out. So this is exactly what's going to happen. So this is equal to negative integral dt over t. I'm bringing the t out, so it's going to be 1 over t times 3 times t negative t squared negative 1. Now you flip this, it's going to be negative t over 1 times dt over t divided by root of, now let me write it like this, negative t squared positive 3 times t and negative 1. This is what I have got. So clearly the t's can be cancelled, so I got a quantity, so I need some space, so let me move to the next page. For 1 second just consider this quantity. Now let me take a negative sign out, and that would give me t squared negative 3 times t positive 1. If I were to write this as a perfect square, so let me show that to you. So this is t squared, negative 3 times t. I am adding 3 over 2 raised to the power of 2 negative 3 over, or negative of 3 over 2 raised to the power of 2 positive 1. Now we can rewrite this quantity. So this can be rewritten as negative of t negative 3 over 2 raised to the power of 2. So when you expand this, you get t squared followed by negative 2 times 3 times t over 2. So that would give me a 3t followed by addition of 3 over 2 raised to the power of 2. So that's fine. So I've got all this. Now I have a 9 over 4 and a positive 1. So this is how it is. So if I were to rewrite this by taking the LCM, so let me write this term again, t negative 3 over 2 raised to the power of 2. If I were to take the LCM here, let me place a positive sign and write these two quantities separately. So this would produce me a negative 9 and this would produce me a positive 4. So this is equal to, or maybe I will use the imply sign. So negative t negative 3 over 2 raised to the power of 2. This is going to give me negative 5 over 4, right? But I've already taken a negative sign. Now if I were to bring the negative sign inside, this is going to be negative t negative 3 over 2 raised to the power of 2. This is going to give me positive 5 over 4, right? So this is nothing but this, right? So I can rewrite this as negative integral dt over root of 5 over 2 raised to the power of 2 negative of t negative 3 over 2 raised to the power of 2. Now we know that integral dx over root of a squared negative x squared. What is this? This is sine inverse of x over a, right? This is nothing but sine inverse of x over a with the arbitrary constant c, right? So we can use this formula. So if I were to use this formula, this can be rewritten as negative of sine inverse of my x is t negative 3 over 2 divided by my a is root of 5 over 2, right? But what did we start with? We started with x positive 1 is equal to 1 over t. So this would mean my t is equal to 1 over x positive 1. So reverting things back, this is going to be negative of sine inverse of 1 over x positive 1 negative 3 over 2 divided by root of 5 over 2 positive arbitrary constant c. So this is a good place for us to draw the red line. So this is a beautiful question, students. I hope you understood this. So now students, we are heading to the last type. Now this is of the form integral dx over a quadratic equation and a root of a quadratic equation, or I should say a quadratic expression or a function. It's not an equation, but it's an expression. So when we are given this, what you have to do is you will have to say, let me just take this example. If you are given some form like this, integral dx over ax squared positive bx positive c times root of, say, some px squared qx positive r, then what you have to do is you have to split ax squared positive bx positive c into linear factors. So how are you able to, or how would you do that? It is possible by using partial fractions, right? So imagine you're given this question, solve integral dx over x squared negative x negative 2 times root of x squared positive x positive 1. So this is clearly of the form 1 over q times the root of q. So what we can do is we can actually rewrite this x squared negative x negative 2 as x negative 2 times x positive 1. I'm just factorizing it. X into x would give me x squared, x times 1 would give me x, added with negative 2x, that would give me negative x, and negative 2 times 1 would give me negative 2. So this factorization is accepted. So this is equal to integral. I'm going to write this as 1 over x negative 2 times x positive 1 times dx over root of x squared positive x positive 1. Now by partial fractions I can split this as a over x negative 2 positive b over x positive 1, right, times dx over root of x squared positive x positive 1. So this is always possible. So now the question comes, the evaluation part. So let me just perform the evaluation over here. So we are actually rewriting x negative 2 times x positive 1 as a over x negative 2 positive b over x positive 1. So if we had to cross multiply this, this would give us 1 is equal to a times of x positive 1 positive b times of x negative 2. So let me take x to be equal to negative 1, this would become 0, and we would have b times of negative 1 negative 2, which is going to be negative 3 times b. On the left I got 1, so therefore the value of b is negative 1 over 3. So having got the value for b, let me also get the value for a. So let x be equal to 2, this would become 0, so I would now have a of 2 positive 1, on the left it's 1, so 3 times a is equal to 1, therefore the value of a is 1 over 3. So I have successfully got the value of a and b. So let us substitute that over here. So this is equal to integral 1 over 3 divided by x negative 2 positive of negative 1 over 3 divided by x positive 1 times dx over root of x squared positive x positive 1. Now I can rewrite this as by distributing 1 over 3 times dx over x negative 2 times root of x squared positive x positive 1. This is one term. The next term is negative 1 over 3 integral dx over x positive 1 times root of x squared positive x positive 1. Now this is similar to the form that we have just performed a minute ago. So what I will do, I will just say consider this quantity integral dx over x negative 2 times root of x squared positive x positive 1. So let me take x negative 2 to be equal to 1 over t. So this would mean x is equal to 1 over t positive 2. And differentiating this quantity would give me dx is equal to negative 1 over t squared times dt. So this is equal to integral, in place of dx I substitute negative 1 over t squared times dt. In place of x negative 2 is 1 over t times square root of x squared. X is 1 over t positive 2 raised to the power of 2 positive 1 over t positive 2 positive 1. I can flip this. This is going to be negative of integral. It's going to be t over t squared. So that's going to be 1 over t times dt divided by root of, I expand this, I get 1 over t squared positive 2 times over t, positive 4, positive 1 over t, positive 2, positive 1. So this is what I've got. Now I can add these two together, so that will give me 3 over t. So let me just write it down. So negative integral 1 over t times dt divided by root of 1 over t squared positive 3 over t positive 6 positive 1 7 is equal to negative 1 over t times dt. I'm going to take the LCM as t squared. So that will give me 1 positive 3 times t positive 7 times t squared. I flip this. If I flip it, I would get t over t times dt divided by root of 1 positive 3t positive 7 times t squared. So clearly these two can be cancelled, and that would give me negative integral dt over root of 1 positive 3t positive 7t squared. Now we will have to solve this. What I would do is I would rewrite this as negative integral dt over, let me take 7 out, that would give me t squared positive 3 over 7 times t positive 1 over 7. Now I'm going to take this root 7 out, so that is going to be negative 1 over root of 7 integral dt over root of t squared positive 3 over 7 times t positive 1 over 7. Now what I wish to do is I would like to use perfect squares to represent this quantity. So I've got t squared positive 3 over 7 times t positive 1 over 7. Now let me just club these two things. Now this can be rewritten as t positive, I need to get 3 over 7 times t. So that is going to be 3 divided by 14. So when I have 2 times AB, I will have 2 there multiplied with 3 over 14 times t. That means 2 would divide 14 7 times. So eventually we will be having 3 over 7 times t. So the second term is already there. Now if I were to raise it to the power of 2, I would have 3 over 14 raised to the power of 2. So I will have to get rid of that. So that's going to be 9 over 14 squared added with 1 over 7. Now let us simplify this. Negative 9 over 14 squared positive 1 over 7. Now if I were to take the LCM is going to be 14 squared. So this is going to give me negative 9 added with 7 will divide 14 squared. 14 squared is nothing but 196. So 7 divides 196 28 times. Now 28 added with negative 9 would give me 19 over 14 squared. So this is the quantity that I have got upon simplifying this. So this is nothing but t positive 3 over 14 raised to the power of 2 followed by positive 19 over 14 squared. So I'm going to take this and I'm going to place it here. So this is equal to negative 1 over root 7 integral dt over root of t positive 3 over 14 raised to the power of 2 positive root of 19 over 14 raised to the power of 2. Now this is nothing but integral, let me write that down here. This is nothing but integral dx over root of x squared positive a squared, which is nothing but ln of modulus of x positive root of x squared positive a squared followed by arbitrary constant c. So I'm going to use this formula. So upon applying this formula, this is going to give me negative 1 over root 7. I'm going to place a flower parenthesis. So we are going to have ln modulus x, in place of x is going to be t positive 3 over 14 positive root of this entire quantity, that's going to be t positive root of 14 raised to the power of 2 followed by positive root of 19 over 14 raised to the power of 2. of course we need to place a parenthesis, but we will have to revert or I should say we will have to go back to the x component because this is t. So let me just show you. Now x negative 2 is equal to 1 over t. Now from here t will be equal to 1 over x negative 2. So in place of t I need to substitute 1 over x negative 2. So if I were to make that substitution, I'm trying to squeeze the output over here. So let me try to do that. So this is equal to 1 over root of 7, right, with a negative sign, and ln of modulus of my t is 1 over x minus 2. So I can substitute that 1 over x minus 2, that's my t, positive 3 over 14, positive root of 1 over x minus 2, positive 3 over 14 raised to the power of 2, positive root of 19 over 14 raised to the power of 2. So we can close the parenthesis and place the arbitrary constant c. Now this is for one part, right? So this is completed. Now we need to work on this. So let's go to a new page and find out the simplification of this quantity. So we expected to simplify and evaluate this. So what I'm going to do, I'm going to say let x positive 1 be equal to 1 over t. From here we can extract x. So this would mean x is equal to 1 over t negative 1. If I were to differentiate this, this is going to give me dx is equal to negative 1 over t squared times dt. So this can be rewritten as negative 1 over 3 integral. In place of dx I will be substituting negative 1 over t squared times dt divided by x positive 1 is 1 over t times square root of x is 1 over t negative 1 raised to the power of 2 positive 1 over t negative 1 positive 1. So let me use this space in simplifying this. So 1 over t negative 1 raised to the power of 2 positive 1 over t negative 1 positive 1. This can be rewritten as, if I were to expand this, this is going to be 1 over t squared negative 2 times t, in other words 2 over t, positive 1 over t negative 1 positive 1. Now clearly we can get rid of this negative 1 positive 1, and then we can add this negative 2 over t and 1 over t. That will give me negative 1 over t. I have a 1 and I have a 1 over t squared. So I'm going to make use of this. So take this out and substitute here. So this is going to be negative is positive. So integral. Now if I were to flip this, this will be t over t squared, right? T over t squared times dt divided by root of, I get 1 over t squared negative 1 over t positive 1. So this is what we have got. Now a t and a t squared can be cancelled. So this is going to be integral dt over t times root of, if I were to take t squared as LCM, I can take t squared as LCM. So if I were to do that, this will produce 1 negative t positive t squared. So I can take the t out. So this is going to be integral dt over t. If I were to take the t squared out, this is going to become t times root of 1 negative t positive t squared. So I can cancel this and this. So that would give me integral dt over root of, let me write it like this, t squared negative t positive 1. So this is what I've got. So now we will have to simplify this. So let me just consider this quantity t squared negative t positive 1. I'm going to club these two together and represent this as a perfect square. So this is going to be t negative 1 raised to the power of 2. If you were to square this, I will get t squared negative 2 times t, but I just have t, so I will place 1 over 2 there. So that would mean I will get t squared negative t and positive 1 over 2 raised to the power of 2. So I need to get rid of that 1 over 2 raised to the power of 2. So I'm subtracting 1 over 4 and I have to add that positive 1. So let us club these two together. So if I were to club these two together, this would give me 4 negative 1 positive 1 positive 4, right? So that would mean I got 3 over 4 there. So in general this is going to be t negative 1 over 2 raised to the power of 2 positive 3 over 4. So I can take this and place it here. So this is going to be equal to integral dt over root of t negative 1 over 2 raised to the power of 2 positive root of 3 over 2 raised to the power of 2. As I mentioned to you, this is very similar to, we know that integral dx over root of x squared positive a squared is equal to ln of modulus of x positive root of x squared positive a squared positive arbitrary constancy. We know this formula. So this is going to be equal to ln of modulus of x is t negative 1 over 2 positive root of t negative 1 over 2 raised to the power of 2 positive root of 3 raised to the power of 2 modulus sign. Now we know that x positive 1 is equal to 1 over t. So therefore t is equal to 1 over x positive 1, right? This is what we have got. So we will have to substitute in place of t 1 over x positive 1. So that in turn is going to be ln of modulus of 1 over x positive 1 negative 1 over 2 positive root of 1 over x positive 1 negative 1 over 2 raised to the power of 2 positive root of 3 raised to the power of 2 raised to the root of 3 over 2 raised to the power of 2 with the modulus sign and the arbitrary constant positive c. So this is the second term. Now what we need to do is we need to club these two terms together. That's exactly what we are going to do, and that would complete the solution. So the final solution is going to be this term. Let me write that down, is equal to negative 1 over root 7 ln modulus 1 over x negative 2 positive 3 over 14 positive root of 1 over x negative 2 positive 3 over 14 raised to the power of 2 positive root of 19 over 14 raised to the power of 2. So this is one term. This has to be added with the second term, is ln of modulus of 1 over x positive 1 negative 1 over 2 positive root of 1 over x positive 1 negative 1 over 2 raised to the power of 2 positive root of 3 over 2 raised to the power of 2 plus arbitrary constancy. So this is the final solution, and this is a good place for us to draw the red line. Of course this question is a little bit tedious, but we can achieve this if we are firm in the concepts. So we'll move on to the next type, students. Now we are going to learn another new type, and that would be integral dx over ax squared positive bx positive c times root of px squared positive qx positive r. So if you are given a form like this, and that b is equal to 0 and q is equal to 0, that means the middle term is absent. Eventually you would be required to solve a form of this nature, ax squared positive c times root of px squared positive r. Now if you were to be given a question like this, the required substitution that you will have to take here is x is equal to 1 over t. So have that in mind. So this is very important. If you make the right substitution, the solution is easily achieved. So what I wish to do is, I would like to do this question, integral dx over x squared positive 4 times root of 4 times x squared positive 1. Both of them are quadratic, but the middle term is missing. So what we will do is we will make the substitution over here. Let x be equal to 1 over t, and from here we would get dx is equal to negative 1 over t squared times dt. So if we were to substitute that, I would get in place of dx negative 1 over t squared times dt divided by, in place of x I will have to substitute 1 over t, that has to be raised to the power of 2 followed by a 4 there, and that has to be product multiplied with square root of 4 times of x is 1 over t, so this is going to be 4 over t squared positive 1. So we will have to perform the simplification. We will use the next page. So let me rewrite it. We stopped at this junction, which is negative dt over t squared divided by, we had 1 over t squared positive 4 times square root of 4 over t squared positive 1. Now if I were to take the LCM, this is going to be dt over t squared divided by 1. If I were to take t squared to be the LCM, this is going to be 1 positive 4 times t squared divided by t squared times root of 4 positive t squared divided by t squared. Now if I were to flip this, this is going to be equal to negative integral t squared will go to the numerator, that has to be divided by another t squared times dt divided by 1 positive 4t squared. Now t squared can be, in fact this t squared can be brought out of the square root. So if we were to do that, that's going to be 1 over t times root of 4 positive t squared. So clearly I can cancel the t squared that I see here. So that is neutralized, giving me equal to negative integral, so I can push it to the numerator. It's going to be t times dt divided by 1 positive 4t squared times root of 4 positive t squared. Now this is simple to solve. Now what I wish to do is I would like to take, let 4 positive t squared be equal to some p squared. This would mean 2 times t dt is equal to 2p dp. So 2 and 2 can be cancelled here. Upon substitution, this is going to be p times dp divided by 1 positive. Now t squared positive 4 is p squared. So from here I can have t squared to be p squared negative 4, right? So I can substitute that 4 times, in place of t squared it's going to be p squared negative 4 times root of 4 positive t squared, that's going to be p squared. So this is equal to negative p times dp divided by 1 positive, distribute the quantity, 4 times p squared negative 16, right, times root of p squared is p. So clearly p can be cancelled, giving me negative integral dp over 4 times p squared negative 16 with the negative sign added with 1, that is going to give me 15. So this is what I've got. Now I need to perform some simplification here. What I would like to do, I would like to take 4 out, so that's going to be negative integral dp over 4 is taken out, so it's going to be p squared negative 15 over 4. So I can rewrite this as negative 1 over 4 integral dp over p squared negative root of 15 over 2 raised to the power of 2. Now what is this? This is similar to, let me use this space. We know that integral dx over x squared negative a squared is equal to 1 over 2a ln of x negative a divided by x positive a, positive arbitrary constancy. So if I were to use that formula, this is going to be negative 1 over 4 1 over 2a, so it's going to be root of 15 divided by 2 times ln modulus x minus a, so it's going to be p negative root of 15 over 2 divided by p positive root of 15 over 2. So this is what I've got. I'm not going to add positive c as of now. Let us first retract, or I would say revert all the quantities, or I should say all the variables to the x component, the original variable. So 2 and 2 can be cancelled, and that would mean this is equal to negative 1 over 4 times root of 15 ln modulus. Now my p is root of 4 positive t squared, right? Because p squared is 4 positive t squared, so my p is going to be root of, so let me place that. So this is going to be root of 4 positive t squared negative root of 15 over 2 divided by root of 4 positive t squared positive root of 15 over 2. So this is what I've got. Now we need to replace t, so that has to be done. So let's find out what t is. Now we have taken x is equal to 1 over t, so this would mean my t is equal to 1 over x. So in place of t, let's substitute that. So it's going to be negative 1 over 4 times root of 15 ln modulus root of 4 positive 1 over x raised to the power of 2. So that is placed here, negative root of 15 over 2 divided by root of 4 positive 1 over x raised to the power of 2 positive root of 15 over 2 with the modulus sign plus arbitrary constant c. Of course, if you want, you can perform some simplification, but I feel that this is the right place for us to draw the red line, and we have completed the solution, students. So this is a beautiful question, and I would like to encourage you all to practice, and practice makes perfect. Students, next we are going to study some techniques for integrating integrals of the following type. Now suppose you are given to integrate integral square root of x negative alpha over beta negative x times dx, or integral root of x negative alpha times beta negative x times dx, then you will have to make the substitution. X is equal to alpha times cos square theta positive beta times sine square theta. We will look into the problems related to these types. Now next, if you were to be given integral of this form, integral root of x negative alpha divided by x negative beta times dx, or integral root of x negative alpha times x negative beta times dx, then you will have to make the following substitution. X is equal to alpha times secant square theta negative beta times tan square theta. Now finally, if you were to be given integral dx over root of x negative alpha times x negative beta, then you will have to make the following substitution. That would be x negative alpha is equal to t squared, or you can make x negative beta is equal to t squared. Either you can use this or this. So the best way, as I always mention to you all, is to do more problems. So let's do that. We have been given this question and expected to solve. Now what I would do is I would take, let x be equal to 2 times cos square theta positive 5 times sine square theta. Of course you are free to interchange the positions of 2 and 5, but I'm just taking it like this. So this would mean 5 negative x would be rewritten as 5 negative, in place of x I will be substituting 2 times cos square theta positive 5 times sin square theta. This can be rewritten as 5 negative 2 times cos square theta negative 5 times sin square theta. I can club these two together, so that would mean 5 of 1 negative sin square theta followed by negative 2 times cos square theta. Now 1 negative sin square theta is cos square theta followed by negative 2 times cos square theta. 5 cos square theta negative 2 cos square theta will give me 3 times cos square theta. So now you clearly know that why I've taken 2 over here and 5 over here, because it gives me the opportunity to simplify this in a rapid manner. Now we will have to now know what is x negative 2. So this is going to be 2 times cos square theta positive 5 times sin square theta negative 2. So I'm going to rewrite this clubbing these two things together. So that's going to be 2 times cos square theta negative 2 positive 5 times sin square theta. So if I were to take 2 out, I would get cos square theta negative 1 positive 5 times sin square theta. Now if I were to take the negative sign out, this would become 1 negative of cos square theta positive 5 times sin square theta. So this is equal to 2 times of negative 1 negative cos square theta is sin square theta followed by 5 times sin square theta. This is negative 2 sin square theta positive 5 sin square theta would give me 3 times sin square theta. So that's fair enough. So this is equal to integral root of 5 negative x is 3 times cos square theta divided by x negative 2 is 3 times sin square theta. Now there is a dx there. We will have to look into the dx. Now x is equal to this, so let's see what happens to dx. Probably I will use this space here. So x is 2 times cos square theta positive 5 times sin square theta. So if I were to differentiate this, dx would be equal to 2 times of differential of cos square theta is it going to be 2 times of cos theta times differential of cos theta, that's going to be negative sin theta positive 5 times of differentiation of sin square theta is going to be 2 times sin theta times differentiation of sin theta, that's going to be cos theta. So this has to be multiplied with d theta, right, this entire thing. So let me rewrite this. This is equal to, so I will have to distribute this. So it's going to be 2 times 2 is 4 cos theta sin theta with a negative sign positive 10 times cos theta sin theta d theta. So this is what I've got. So I can simplify this, right? So if I were to simplify negative 4 cos theta sin theta with positive 10 times cos theta sin theta, this is going to give me 6 times cos theta sin theta d theta. So this is my dx, right? So I need to substitute my dx there. So this is equal to, let me write that down, this is going to be, now clearly the 3 that you see here will be cancelled. So root of cos square theta would give me cos theta, root of sin square theta would give me sin theta. Now I have 6, of course I can place the 6 here, 6 cos theta times sin theta times d theta, right? So what I can do is I can cancel the sin here. This is going to give me 6 times cos square theta d theta, but cos square theta is 1 positive cos 2 theta divided by 2 times d theta. I can rewrite this as 6 integral, in fact I can take the 2 out, so it's going to be integral d theta positive integral cos 2 theta times d theta. So This is equal to 3 times integral d theta is theta positive, cos 2 theta is sin 2 theta divided by 2.